shoring is the process of bracing the walls of a trench to prevent collapse. These methods include steel sheet piles, cofferdams, soldier piles and leggings, and linear shoring. These are several images of different types of method used to shore up a trench.
Steel sheet piles are long structural sections with a vertical interlocking system that creates a continuous wall. Advantages of them are high resistance to driving stresses, can be used in various projects, and their pilings can be easily adjusted by either welding or bolting. Disadvantages is that the depths may be difficult to achieve in soils that have boulders or cobbles. Secondly, the sheet piles driving may cause disturbance to neighborhood areas. A cofferdam is a structure that retains water and soil, allowing the enclosed area to be pumped out and excavated dry. Cofferdams are commonly used for constructions of bridges, piers, and other support structures built within water. Advantages of them are the steel sheet piles can be easily constructed and removed. The materials can be reused on other future projects, and it allows constructions in poor state environments. Disadvantages of them is that they require special equipment, they are relatively costly and not economical, and they require tedious and time-consuming work process. The third shoring method is soldier piles. They are one of the oldest forms of retaining systems used in deep excavations. They can be seen used all the way back in the late 18th century. The advantages of soldier piles are they are fast to construct, cheaper in cost as compared to other systems, and they don't require advanced techniques. The cons of soldier piles are they're primarily limited to temporary constructions, they can't be used in high water table contents, and they are not as stiff as other retaining systems.
Linear shoring is a system that is high in terms of providing safety, having minimal impact on the ground, and allowing as much working space as possible. Linear shoring consists of the single slide rail system and double slide rail systems. The diagram below shows the different components of the linear slide rail shoring system. The main components are the panels, the corner posts, and the linear rails. The linear rails are spread apart by a spreader beam and roller beams. They are also known as the strut cut.
Linear shoring is a highly effective trench support system. It is used to replace the conventional method of using wood or steel sheathing. In this system, the excavation can be taken place at unfavorable ground conditions or where an existing underground infrastructure would pose difficulties in trench support. The advantages are that it's cost-effective, saving money in labor and materials. It eliminates the risk of collapsing, which provides safety for the workers during excavation. And lastly, no damages to adjacent building structures or traffic.
To talk about a project that are using linear shoring in Malaysia. A project in Malaysia that uses linear shoring is Mano KL, which is a 46-story condominium located right next to KLCC, is in the middle of the KL city. Among the projects that require this shoring system are projects that are located at restricted areas. For example, downtown areas are highly populated and cannot cater large machineries. It is also used at sites which are adjacent to buildings and require minimal vibration. As Mano KL is constructed in the center of KL, which is right next to KLCC, Istana Police, Istana Terengganu, and such buildings, the linear shoring rail system is useful as minimize transportation costs in and out of the city. It is also used smaller size excavator which will cause less disruption to traffic as well as less vibration compared to other methods. And also the installation and removal time of the system is very minimal and will decrease the overall construction cost. So they are using linear shoring system in this project.
Linear shoring acts as a support during trench excavation. Proper linear shoring provides adequate support to the size of trenches and prevents the caving in of soil. Effectively, it provides safety for workers during excavation as it reduces the possibility of a cave-in while work is being carried out in the trench. Here are a few examples of workers in trenches without proper shielding from bare soil.
The installation of a single slide rail system begins with a pilot cut. It is not shown in this animation but will be shown in following slides. It is basically a trench around 4 feet deep. Then the outer panel is lowered into the cut. The panel is usually backfilled on each side so it stands by itself. The corner rail is dropped over the end of the outer panel. Another pilot cut is dug 90 degrees from the first panel and a corner rail is installed. A third pilot cut is also made 90 degrees from the first panel. The length between panels is measured to ensure the panels are exactly parallel. The enclosure is called the bay. The soil within the first bay is excavated. The strut cut and linear rail is lifted into place and lowered over the end of the outside panels to set a constant width of slide rail system and to stabilize the system during and after installation. Excavator buckets are used to drive corner rails and outer panels securely into the soil. The process is repeated until the entire system is in the soil. To install the second bay, make pilot cuts and repeat the entire process. Additional panels can be added for greater depth. These panels are called inner panels. They are lowered into place in between corner rails alongside the outer panels. Inner panels are lowered by the excavator bucket while outside panels remain stationary. Inner panels are used to reach the required depth. To recap, a pilot cut looks like a trench as shown in the picture here. After the first, second and third panels are installed, the soil is removed and the strut cut and linear rail extension is placed. The picture here shows the strut cut being slided into the linear rails. The strut cut and linear rails will allow the system to be as long as you need it to be, and additional panels will allow to be as deep as you need it to be.
Single slide rail system is used mainly in middle-sized range construction where high strut clearance are required and the terrain tends to setting, and has only one track guidance for the sections of the shoring patch which are equipped with special T-shirt side abductors to slide into rail. And for the last point is step up to 3.8 meter can be achieved. For the double slide rail system is used in deep trench construction where high strut clearance are required, and also offer a 2-track guidance which subsequently allow for deeper trench depth. For the last point are available for a trench depth up to 7.5 meters.
To ensure a smooth excavation, it's important to foresee the problems occur on site. So what would go wrong during shoring? Faulty workmanship, insufficient technical skills or failure to follow proper construction procedure will lead to shoring errors. Not to mention negligence of safety rules. For instance, if there is no proper inspection done after rainstorms or any changes in soil conditions, cave-in or slide will affect the shoring system and safety of workers. Thirdly, installation process will be affected if the materials used for shoring are not in good condition or in wrong sizes, such as inconsistent size of corner rails or rusty bolted joints. Apart from inappropriate type of soil use, shoring system will sink or tilt when backfilling is not done properly. Settlement of nearby structure will possibly occur due to instability of soil. Heavy machinery must be available in order to handle the weight of the slide rail frame. Wrong or defective equipment may lead to a leader accident. Next, problem of misalignment will affect trench boxes shoring system. If previous panels and posts are not erected precisely, the fourth panel will not fit in between of the rails. The panels in the outer slides stay approximately 10 cm above ground level, otherwise soil will roll into the pit. Even for shoring structures of high tensile material, as you can see in the images, inadequate or faulty structural design will result in cases like inward bowing of the panels, bending of posts, shoots with lateral buckling.